We're going to talk about equations of ellipses and a theorem. We're in Algebra 2 at 10.3b now. We have 8 previous videos. If you become lost or confused, click on the description to find those previous videos to fill in what you missed. So as we said in the previous video, some equations of second degree have graphs that are ellipses. Now I have a theorem for you. The equation in standard form of an ellipse centered at the origin. That's really important. This is for the origin center. With foci on an axis and c units from the origin is the quotient of x squared and a squared plus the quotient of y squared and b squared will equal 1. And that's if the major axis is horizontal. Or it would be the quotient of x squared and b squared plus the quotient of y squared and a squared equals 1 if the major axis was vertical. And that's where c squared equals a squared minus b squared. Now, the foci lies c units away from the center. So that's why this equation is important. It helps us find the foci. And we can use this c squared equals a squared minus b squared, like here, or we could flip it around and do b squared minus a squared to find the foci, depending on which is larger, a or b. And the value of c squared has to be positive because we can't have a negative amount away from the center, can we? For the ellipse, x squared plus 16y squared equals 16, we can find the vertices and the foci and draw a graph. We first multiply by 1/16 to find the standard form. So, because it equals 16, we're going to multiply each term by 1/16 to find the standard form. And we get x squared times 1/16, which would be a 1/16 x squared, wouldn't it? So we can just say x squared over 16. This would be 16 over 16y squared, so it's y squared over 1. And 16 over 16 is a 1. We can also say that this is 4 squared, isn't it? And that is 1 squared. And then that would fit our equation from our theorem. Now, since the denominator for the x squared is larger, the foci are on the x-axis and the ellipse is horizontal. So a is equal to 4 and b is equal to 1. And the vertices on the major axis are a -4 and a 0 and a 4 and a 0. And the vertices on the minor axis are a 0, -1 and a 0, 1. Now, using this equation, we do 16 minus 1, that gives us a 15, and we get rid of this exponent 2 and put the radical around the 15. We get c is equal to the square root of 15. And the foci are at -15, 0, square root of 15 and 0, and the square root of 15 and 0. To graph this, we plot the vertices and draw a smooth curve. So we plot all our vertices, we put our dots where the vertices are, and then we just slowly make a nice curve going around it. And we know that our foci are at these points, and square root of 15 is approximately 3.87. So we can put those in, and now we have our ellipse that's horizontal with our foci and our vertices. Okay? Let's try this again. We can find the vertices and foci and then draw the graph for this equation. 9x squared plus 2y squared equals 18. Now because it equals 18, we're going to first multiply each term by 1/18 to find the standard form. So we do that to each term. We get 9/18 x squared. We get 2/18 y squared and 18/18. That'll give us half x squared and 1/9 y squared and a 1. We can rewrite this as x squared over 2 plus y squared over 9 equals 1. And following our equation from our theorem, where the denominators are square, we can get, because we need to find the square of 2, so we just write it as the square root of 2 squared, and that is 3 to the second power for the 9. Now, since the denominator for this one is larger, the foci are on the y-axis, and the ellipse is vertical. So a is equal to the square root of 2, and b is equal to 3. And the vertices on the major axis are 0, -3, and 0, 3. And the vertices on the minor axis are negative square root of 2, 0, and square root of 2, 0. and square root of 2 is approximately 1.4. Now, because b is larger than a, see, I'm going to use that flipped around version of the equation of b squared minus a squared. So we get 3 squared minus the square root of 2 squared. That's going to give us 9 minus 2. When we have a square root sign and a 2 exponent, we can just take them off and get a 2, remember? So 9 minus 2 is 7. So we get rid of this exponent, give a radical to this side, and c is equal to the square root of 7, which is approximately 2.65. The foci are at 0, negative square root of 7, and 0, square root of 7. So now we can draw it. We plot our vertices, we make our little points for our vertices, and then we draw a smooth line, and then we can put in where our foci are. See? It's approximately 2.65 for square root of 7. See? That's a vertical ellipse. All right? That wasn't too bad, right? I hope not. Our next video, 10.3c, we're going to do ellipse, standard form equation, and completing the square. So I have a little bit different standard form of an equation for you. And I'll put this in the Algebra 2 playlist, and I'll have a link to those 8 videos for Chapter 10 in this description, so you can just click on them, okay? We're getting a little deeper into all this, aren't we? If you're having any trouble, let me know. You can comment below. Don't forget to hit the like button if I've helped you, and I'll see you next video. Bye.